Okay, this is going to be the video for 3B, Counting Atoms Part 1. I do need you to make sure that you take out a periodic table because I'm going to refer to one frequently over the course of the video. So you do want to take out the, I have this periodic table that we use for our tests and quizzes, but you need a periodic table to reference as we're covering the information. Alright, so we're going to go ahead and get started with this. And as we're getting into counting atoms or numbers, there's some topics that we need to define first. Okay, the first one is going to be atomic number, or it's abbreviated as Z, and the atomic number is the number of protons. Okay, now the number of protons is very important because all atoms of the same element have the same atomic number or the same number of protons. Okay, I often refer to this as the atom's DNA because the protons are what are going to designate something as a certain atom. For example, carbon, its atomic number is 6. So every atom that has 6 protons in it is automatically going to be carbon. Electrons and neutrons can change, but protons define what something is. They also determine the order of the elements on the periodic table. The numbers 1 to, about 118, I think is what we're up to now, is going to be that number of protons, and that's what's going to define an atom. We also have to talk about isotopes. Isotopes are atoms of the same element with different numbers of neutrons. Okay, different numbers of neutrons, or in other words, different masses. Different masses for that. So, most elements exist as a mixture of isotopes. Okay, so they're not all completely identical. If you scroll down here, you'll see carbon 12, carbon 13, and carbon 14. Now, I just told you that the protons are going to stay exactly the same. What will change is the neutrons. Okay, for different isotopes, you can have different masses, and this is mostly due to different numbers of neutrons. Okay, and that's going to define, explain to us how we end up with different isotopes. Now, the mass number is designated by this letter A, and it is the sum of all of the particles in the nucleus. Now, that's going to be the number of protons and the number of neutrons, because we've already learned in this unit that the protons and the neutrons make up the nucleus, and then we've got the electron cloud outside of that fact. So, for example, if we look at the mass numbers and the atomic numbers of both chlorine and carbon, okay, we're going to try to discern that fact, and we'll just arbitrarily pick one that has a 1-to-1 ratio because that's the most common for elements that are this small anyway. So how do we figure that out? Well, we go to the periodic table and we find carbon and we find chlorine. Okay, now here's carbon right here. When we find carbon and it has a little key over here, the atomic number is the number that's on top. Okay, so for carbon it's going to be number 6. And so then if we come over here to chlorine, the atomic number is going to be 17, again because it's that top number right here. Okay, so carbon is going to be 6, chlorine is going to be 17. Now, so to answer that on the slide, the atomic number, like we said, for carbon, the atomic number is going to be equal to 6. And we're going to learn about nuclear stability a little bit later, but the pattern that is present is that most elements below atomic number of 20 have a 1-to-1 ratio. So if we just pretend that this is a 1-to-1 ratio, then we're going to have a mass number then, it's not going to let me write, our mass number here is going to be 12. 12 protons, 6 protons and 6 neutrons. Now with chlorine, the atomic number is going to be 17, so our mass number here is also going to be 17 times 2, because you get 17 protons and 17 neutrons, so we end up with 34. Okay? Alright, now moving on here, designating isotopes, there's 2 ways to write these. You can either have hyphen notation, which is going to look like this. For example, it's the name of the element and then the mass number, which again is protons and neutrons added together. So for example, you have the hyphen, hence the name hyphen notation. The nuclear symbol notation is a little bit different. You have the chemical symbol, and then you write the mass number and the atomic number. Now the atomic number is going to be, remember, the number of protons. Mass number, I know it's a little bit tough to read, but it's what is working right now, is the number of protons and neutrons. Okay, so those are going to be things that we need to make sure that we understand. And again, back to our little carbon 12, carbon 13, carbon 14, just as a reminder, every single one of these is carbon, so they're all going to have 6 protons, 6 protons, 6 protons. What's the only thing that's different about them is the number of neutrons, and you can go in and you can count here, or you can remember that this is the mass number. So if carbon 12 means there's 12 total particles in the nucleus. Well, if 6 of them are protons, I know that 6 of them have to also be neutrons. And I can count there's 6 blue dots and 6 red dots. Now, carbon 13, we're now up to 13 particles in the nucleus. Now, I've already told you that there can only be 6 protons because it's carbon and that's its atomic number. It's the way it is. But since the mass number is 13, it means we're going to have 7 neutrons here. Okay, 7 neutrons. And then carbon 14, again, it's still carbon, so it's still 6 protons. We're up to 14 particles in the nucleus, which means that we're going to have 8 neutrons. Okay, 8 neutrons. Now, for some samples here, if I have an element that has 7 protons and 8 neutrons, my hyphen notation is nitrogen-15. My atomic notation, or my nuclear symbol rather, is going to be nitrogen. I put 15 up top because that's the mass number. Again, mass number. And then the atomic number is going to be 7. 1, because it told us. 2, if I find nitrogen on the periodic table, if you look at your periodic table, nitrogen is the 7th element. Now, for the second one, I've got 17 electrons and 19 neutrons. Now you may be going, well, how the heck am I supposed to figure it out? Well, it's got to be chlorine 36. And the reason it's got to be chlorine 36 is that we already found out that there are 17 protons in an atom of chlorine. Well, for right now, the protons are going to equal the number of electrons. So if I know how many electrons there are, because most atoms are neutral, I can work backwards. So that's where I get chlorine 36. And for my nuclear version, I put the symbol, I put the mass number up top, which is 36, and the atomic number down here, which is 17. Okay? So there's just some examples of those. Now, just to show you as a reminder, some of these abbreviations, Z, if you remember, is going to stand for atomic number. So as soon as we see that the atomic number is 5, the element that we're dealing with is the 5th element on the periodic table. So again, where am I getting that from? I want to keep that. If I look on the periodic table, 1, 2, 3, 4, 5, I'm dealing with boron. So as soon as they tell me the atomic number, it's the number of protons. In this case, it's going to be boron. And boron 11. And so then also when I write the nuclear notation, it's going to be a capital B, mass number up top, atomic number down below. Okay, then I have A. If you remember, A is going to stand for mass number. I just remember it's always kind of opposite. I would think A would stand for atomic number, but it doesn't. So it's the opposite. I don't know if that helps you or not, but so it works in my brain. Okay, since it told me that I have 75, my mass number is 75, if I take 75 and I subtract 42, that's a bad 2, but it's my highlighter that's not working out very well right now, I'm going to be left with 33. If I find the 33rd element on the periodic table, I find that it's arsenic. It's going to be arsenic, and you're going to have 75 because the mass number goes up top, and the 33 goes up. So this would be a chart that we should be able to fill out based on what I've kind of already told you. So up here you've got protons, neutrons, electrons, and then remember Z is going to be your atomic number and A is going to be your mass number. So if we go and we find carbon, if you look on your periodic table, you're going to remember that carbon is the 6th element. So as soon as we figure out the number of protons, it's also the number of electrons, and remember Z is also the atomic number. So those 3 numbers are always going to be exactly the same. The mass number, they tell me out here, it's going to be 13. And then if I work backwards here, in order to figure out the number of neutrons, I just subtract the difference between these 2 numbers right here. Okay, so 13 minus 6 is going to be 7. Okay, so then I can fill in the chart. Now down this one, you may be going, well, how do I know which atom it is? Well, again, this column right here, the number of protons, if you go to your periodic table and you find the 54th element, okay, the 54th element is going to be xenon. So we're going to know it's going to be xenon. And remember, I did tell you the number of protons is equal to the number of neutrons, so I can fill in my 54. And then in order to get the mass number, which is A, I have to add these two boxes right here. So I'm going to take 54 plus 77. It's going to be 131, which is going to go there, and 131, which is going to go there. Okay? Now the next one, I've got sodium 24. So if I fill this in, I figured out it's sodium. If I go to the periodic table, I find sodium on the periodic table, I'm going to find that sodium, and sodium is a little bit tricky. It's one of those elements that the unit, the abbreviation almost looks like it doesn't match. So sodium is the 11th element on the periodic table, okay, which is right over here. It has to do with the root languages of where some of these names came from. So once I know it's sodium, I find it, I see that number 11, and then that will give me enough information to fill in the rest of the chart. So sodium's the 11th element. Let me get back to something that we'll write here. I put an 11 here, and 11 here, and 11 here. Good news, all three of those are still always going to be equal, 4 right now. We're going to change that here in another unit or two. And then my number of neutrons, I subtract these two numbers right here. The difference between them is going to be 13. Now I'm going to work opposite here. They haven't told me which element it is, so if I find the 8th element on the periodic table, it's going to be oxygen. And since there's 8 protons, there's going to be 8 electrons. My mass number here, they've already told me, is going to be 15. And then my number of neutrons, again, I subtract those two numbers, and it is 7. Okay, and it is 7. Now this next chart on the next slide is going to be very similar, except it uses the nuclear notation. So for lithium, again, this gives you more information. It tells me the number of protons right there, so that's also going to be the number of electrons and the atomic number. All three of those are equal. The number of sorry. If you remember, this is the mass number, and this is the atomic number. Okay, so my mass number goes right here. Mass number is A. Difference between these two is going to be my neutrons. Now to figure out which one this is going to be sodium, which is Na. My mass number goes up top, 22. My atomic number goes down the bottom, which is 11. Here's beryllium. You've got 4, 4, and 4. My mass number is 8, and my number of neutrons is 4, because that's the difference between those two numbers.